Section 7-4 is on the remainder and factor theorems. For number 14, you are to use synthetic substitution to find g of 3 and g of negative 4 for each function. So what you do is you put 3 in the box for synthetic division, use your leading coefficients in the polynomial, skip a line, draw a line, bring down the 1. Multiply 1 times 3 is 3, and then add, you get 5. 5 times 3 is 15, add, and you get 12. 12 times 3 is 36, add, and you get 37. This last number is going to be your answer, which means g of 3 equals 37. You can check your answer by plugging in 3 into g of x. So g of 3 equals 3 cubed plus 2 times 3 squared minus 3 times 3 plus 1, and you should get 37. When you have g of negative 4, you are to put negative 4 in the box and use the leading coefficients 1, 2, negative 3, and 1. Skip a line, draw a line, bring down the 1. Negative 4 times 1 is negative 4. Add, you get negative 2. Negative 4 times negative 2 is 8, and you get 5. 5 times negative 4 is negative 20, and add, and you get negative 19, which means g of negative 4 is equal to negative 19. Again, if you want to check your answer, you can plug negative 4 into the polynomial. The next two problems, 21 and 27, you are given a polynomial and one of its factors. Find the remaining factors of the polynomial, and some factors may not be binomials. So here we go. If they give you a factor of x minus 1, the 0 goes in the box, which means a positive 1 goes in the box. 1, 2, negative 1, and negative 2 are your leading coefficients. If x minus 1 is a factor of the polynomial, our remainder should be a 0. So let's go. 1 times 1 is 1. 2 and 1 gives 3. 3 times 1 is 3. Negative 1 plus 3 is 2. 2 times 1 is 2. 2 and negative 2 gives 0. So our remainder is 0, which means it is a factor. Now, if the polynomial was a third-degree polynomial, this means we have 1 power less, x squared, plus 3x plus 2. To get the other factors, we are able to factor this further. X and x gives us x squared. Factors of 2 that add up to 3 are 2 and 1. So these two factors are other factors of the polynomial for 21. For number 27, we cannot use synthetic division since our leading coefficient of what we're dividing by is not a 1. So you have to use long division. 2x plus 1 into 2x cubed plus 7x squared minus 53x minus 28. We have to divide the polynomial to find the other factors. 2x times x squared gives us 2x cubed. Whatever you put on top, remember you have to distribute. X squared times 1 is x squared. Subtract. 2x cubed minus 2x cubed cancels off and gives you 0. 7 minus 1
Janelle Davis, please call 763607. Janelle Davis, 3607.
Then you have to do the process again. 2x times what is 6x squared? It'd be 3x. So 3x times 2x is 6x squared. 3x times 1 is 3x. Subtract. This cancels off. Negative 53 minus 3 is negative 56x. Bring down the next term, which is a negative 28. 2 times what gives us negative 56. That would be a negative 28. So you get negative 56x, negative 28 times a positive 1 is a negative 28. And when you subtract, you do get 0 here. Negative 28 minus 28 is also 0. 2x plus 1 was a factor of that polynomial, so a remainder of 0 makes sense. It goes in evenly. Now what we need to do is take the quotient and factor that further to get our other two factors. X times x gives us x squared. Factors of 28 that have a difference of 3 are 7 and 4. To get a positive 3, we need a positive 7 and a negative 4. Our answer is x plus 7 and x minus 4 are the remaining factors.